Hello, welcome to the electrical engineering class. Today I want to take kind of introduction before new series of lecture begins. In the new series, we are going to learn AC machines, specifically transformer and induction motors. Actually, I already took the first induction motor lecture video. Anyway, what are the things in common of these two devices? Well, they both use electricity as an energy. Alright, so let's see transformer first. So transformer, what does transformer do? Transformer is the device which can change the magnitude of the voltage. So input is electrical energy. I just like EE as abbreviation, electrical energy, and output is also electrical energy. Alright, same energy form, but voltage level switching. So how about the AC motor? AC motor, as you know, is a rotating device. So input is electrical energy, but output is mechanical energy. Right? So this is, in this question, this is AC motor. But how about the opposite line? I mean, input is mechanical energy and output is electrical energy. What's this? This is generator. This is generator. So same machine, same hardware machine, you can use both way depending on your connection. So this is motor and generator. So okay, let's see what is energy. All right, so what is energy? Energy is nothing but power into time. All right, so what is power? Power is nothing but voltage into current in electrical energy. So let me write here. Energy is voltage into current into time. Right? Voltage into time is power. Power into time is energy. All right. So how about unit? Volt, ampere, second. Volt times ampere is watt. Watt times second is joule. All right. Joule is energy. So so time is nothing but just time, right? Just operating time. So if you're operating the transformer for 1 hour or 5 hour, whatever, just some time t. So if I take the input is voltage 1 and current 1 is I will get voltage 2 times current 2 t time. This is the same time, right? So we can cancel it, right? It's the same time t. So so this is a transformer operation. So the one set of from set of the voltage and the current, we will get another set voltage and current. Of course, they're assuming there are no losses. So this is a transformer operation. And so, okay, maintain assuming there are no losses. If voltage increase, current decrease, voltage decrease, current increase. So this is one of the reasons for installing the transformer, the power transmission line, to reduce losses by changing the current level, because the transmission lines losses is proportional to the square of the current. So like that. So we will come to it. So how about the AC motor? So input is transformer has losses themselves, and practical transformer. Actually, it's relatively small compared to other devices, but still they have. Normally, like let's say 92 efficiency. So if input is, let's say 100 joule, we will get only 92 joule because of the losses. But neglecting this transformer losses, this is what is happening. Okay, this is this formula. All right, so how about the AC motor? So input is similarly voltage and current into time. So how about the mechanical side? All right, so okay, first is focusing the straight line. Linear state, a line motion. So in the line motion, we'll get the basic one, force into distance. What is force into distance? Is work done. Work done, right? So this is a straight line. So let me convert a little bit. If divided by t and multiplied by t, so what is this? Divided by t, multiplied by t, this is the same equation. And okay, here's the thing. T and t, it's the same time. So we can express like some term times t. All right, same t. So okay, the point is this term here, this term, right? So distance by time is velocity, right? Velocity. So so this is a force into velocity into time, okay? But again, this is a straight line motion. So how about the circular motion? I mean, motor is rotating device, so we need to convert it to some circular motion. So okay, force will be called to torque. All right, torque. And distance divided by time is nothing but omega. Okay, radians per second. This is the end time. This is the in the circular motion mechanical energy expression. Torque times omega times time, right? So okay, this is it. Okay, so let's think just one example. So if okay, let's say the voltage is 100 volt, and current is taken by the motor. So let's say 10 ampere. So the input is 1000 watt power. So how about the mechanical energy? How about torque? How about speed? It's depending on the rotor requirement. So, okay, let's say if within 1 minute, if within 1 minute, 200 times rotate, for example. So 1 minute, 200 times, 200 revolution. How is it called? This is 200 RPM, revolutions per minute. So, okay, let's convert to radians per second. So let's say 1 revolution is going to 2 pi radians. So 200 RPM. So 200 times 2 pi and 60 by 60, because it's a second from minute. All right, this is my omega. So let's roughly calculate it. So let's say cancel 0 and just assume 3.115 is just 3, so it's cancelled. So omega is 20, right? Okay, omega is 20. So how about torque? Torque is nothing but 1000 divided by 20. So torque is 50 Newton meter. All right, does it make sense? I'm writing very approximately, so you can calculate all the time. But the point is, we can convert from voltage into time to torque into omega, right? From electrical energy to mechanical energy. So how about torque? How we get the torque? This is from the road requirement. So, okay, let's think one example. So, alright, so let's say if there are some item like block or bricks, it's kind of block or bricks, and they have a weight, much weight, and I needed to transport it to, like 20 floors, 24, and each floor is, let's say, 5 meters. So 5 times 20 is 100 meters. So we needed to transport it to 100 meters. Okay. Within 2 minutes. Within 2 minutes. So, okay, so let me put the, kind of wheel here and tie a rope like that, and start to pull it, right? Pull it. So we already know the, torque and speed, right? Torque we know, speed we know, omega we know. Omega is the how fast we move it. Okay, so we already know this state. And voltage also we know because it's a supply voltage. So we already connecting it, 100 volt or 20 volt, whatever. It's a supply voltage, so it already fix it. So that means the current is changing depending on the load requirement. So current is changing. So if we need more, we move it more faster, more current we are taking, and so on. Okay, so one last example. Okay, let me introduce one last example. So this is transformer AC motor. So how about the gears in mechanical gears? Okay, something like that. Okay, something like that. So input is mechanical energy, output is also mechanical energy, right? And input is, similarly torque into omega into time is equal to secondary gear torque into omega into time, right? So let's say if this first gear has a 100 teeth and secondary has 25 teeth, for example, and the gear one is rotating to clockwise direction, and the gear second is opposite way by omega 2, speed omega 2. Right, so which one is the first? Of course, the second gear is more because it's a small, right? So while the first gear rotates one time, gear second is rotated 4 times. Okay, so let's say the torque 2 is becoming 4 times less, but the speed will become 4 times more. So it's kind of the relationship like transformers, electrical energy side. So this is a mechanical gear mechanism for mechanical engineering, same as transformer for electrical engineering, and motor and generator, kind of hybrid concept, something like that. So we are going to learn what is happening, what is inside construction or working principle, or how to maintain this relationship or something. Okay, so we will learn more detail, something like that. Okay, so this is kind of brief introduction of the new series lecture. So we will get induction motor first.